Hi everyone, this is a tutorial for EasyROB. In this example, we are going to start the process from a ChemDraw file with some Palladium extractors and catalysts in there. So first of all, let's check the information that we have in the ChemDraw. Here we have some extractors that we draw in the file and nothing else. So now we are ready to start the process. First of all, we have to start the process checking the enable ACME workflow in order to load the ChemDraw file and then generate the descriptors using ACME. So let's check it and then go to the ACME tab, and we have to click in generate CSV from a ChemDraw and browse our file. In our case it's the Palladium file. Let's open it and then continue. Now we have charted the molecules as smiles here, and we have to fill all the information in all the molecules that we have. First, the code name, in my case is mol1, then the target. This project is trying to predict the quantum yield, so we can change the name of the column and then put the different values of our molecules. Here in ACME we have some different parameters that we can change, and we are using here the charge, the multiplicity, and the complex type of the catalyst. So in each molecule we can put different values in the charge and the multiplicity, like in this case is 0, and the multiplicity of this one is 1. Also we can change the complex type, and in this Palladium catalyst is a square planar. In other cases, like iridium catalyst with six ligands, or copper catalyst with 4 ligands, they present a geometry like octahedral or tetrahedral. So ACME use these values as default, so you don't have to specify any. But in this case, with the Palladium, we have to put the square planar. So now we have to put all the information of each molecule, and then we have to save a CSV file. Once we save a CSV file, the program is gonna load the CSV automatically, and then we can follow with the process. Once we complete the information and save the CSV file, the program automatically loads it. As we can see, a common subextractor is detected in a mono Palladium catalyst, and here we can choose whatever we want in order to generate atomic descriptors in addition to the molecular descriptors that we are going to generate later with ACME. In the case of a methyl-based catalyst, if we don't select any specific atom, the ACME program is going to be able to automatically detect the methyl and generate atomic descriptors for the methyl. But if we select some atom here, we are going to generate only descriptors for these atoms. So once we explain this, we are gonna let ACME to generate the descriptors on the metal automatically, and let's continue with the process and fill all the variables that we have to put in the robot workflow. Now we can continue with the process, and we have to select the different parameters of the robot workflow. First is target column, that is quantum yield, is the target that we want to generate predictions with our model. Then the prediction type is regression. Then the name column is codename, and the enable ACME workflow is already checked in order to generate descriptors with ACME. So now we can run Robert, and first it's gonna generate the descriptors with ACME, and then it's gonna start with the Robert workflow. We talk about the Robert workflow in other videos, so if you want to know more, check it later after this video. And now we have to wait for the process is finished, and we will see the results. Once the process is finished, we can go to the results tab, and here we can check the report that we generate in the Robert workflow with all the metrics and the summary of our machine learning model, our machine learning predictor. but also we can check this report in the folder where we launch the program. Here we have the report, and also we have the folders that we generate in the whole process, the ACME and the different modules of Robert. Here also have a CSV file with the descriptors that we generate with ACME. If we open the file, we will see different columns that represent different descriptors, and we can check that some columns are from the palladium, so these columns are atomic descriptors for the methyl, but also have a column for descriptors of the whole molecule. So that's all for the moment, so thank you so much for watching and see you next time.